All right, so what I put together is basically a model of a CNC machine. I did it about as quickly as I possibly humanly could. Um, so I'm trying to test some concepts on motion control and so what I got set up is a couple stepper motors. I got the timing belts on both sides so that it doesn't rack. I used a drive shaft across, flexible couplings on each side, and so that over there, the other bearing end is actually a rotary encoder, and that's going to allow me to kind of um, determine position. And I've done the same thing on this side with a rotary encoder as my other bearing block, and basically they're just clamped into the back of the blocks and stuff. And this model may actually be sufficient. Again, the belt is, joined underneath these clamp. So what I'm going to do is the model may be sufficient for ultimately what I'm going to try to do. Everything's running nice and smooth. So if you saw in my previous video, basically this is going to combine the ideas from two other videos. The last video that I did was on training a robotic arm, where you can control the arm and make it do things, but you don't have to actually program it. So I used a joystick that was a model of the arm to move the arm the way I wanted it to, and I recorded its positioning, and then I was able to replay those positions. So I didn't actually have to tell it go X, Y, Z, whatever. I just basically, and so what I'm going to do with this is I'm going to try the same thing, and using these rotary encoders to get the position of it wherever it may be, just relative, positions. So I'm going to hook these up to an Arduino that will output the results to a computer, and I'm going to record all of that. So I'll just move all of this by hand. I'll have a stylus coming down, and I'll just draw some outline. Mostly this is for artwork kind of things, plasma cutting, stuff like that. So I'll move it, I'll record all the positions that I make, and then I have a program that will translate all of those to XYZ coordinates, well, XY anyway, and then I'll be able to play the movements back through the stepper motors. So record, replay. And I'll use Mach 3 for that. So I don't really know if this is going to work as well as I want it to. So basically I just created a mock-up model, and then we'll see how it works out. And, ultimately what I want this to control is my plasma table, which works through a stylus. It's more of a plasma tracer. That way I can, follow the design, have it be able to replicate it, but without having to go through all the G code and all the other stuff. It'll just do it for me. So that's where we're headed, and this is where we're starting. And we'll be back in a minute with the electronics hookups. All right, so we got it wired and pretty much tuned. We're running at about 700 inches a minute. It's actually a little dangerous fast. And then as far as configuration, let's see, we're going over here, and let's see, we're gonna let's go home. Really? And so we should end up right on our 0 point. So everything's working good so far. Might even slow it down some, but that'll be good for the plasma cutting. And then, so now we're going to start wiring our encoders. Right, we're ready for our first live test here. I'm going to be using the encoders, and I'm going to do some movements on the table to some of these grid lines. I know the grids aren't perfect. My tool holder wouldn't hold the marker except by the very end, and then it kind of wiggled, but doesn't matter. Good enough for now. So I'm going to be moving that. We have it going to an Arduino, and then we're going to be reading the output with Visual Basic 6 program here, and we're already connected, so I'm just going to move this real quick so you can see the output. So the first line is going to show the wrong coder output. The second line down is going to show the raw XY coordinates in inches. And the reason we got big numbers down there is because I didn't zero it from the last time. So now I'll just give it a little touch. All right, so I mean, this is very delicate, like it's thousandths of an inch. And I don't know how, we'll see about accuracy in a second. This is actually my first test. So what we'll do is we'll hit save point, and then it will save the point down here. If we had put a description in, then it would add it as a comment there. And what it would do is when I hit copy output, it'll add dwell codes between each of the points. And I'll do this a little bit different through like mock automation. So right now, the general idea of it is, and I mean, again, this is a first test, but in this mode, what I'll do is I'll like lay a part on the table. I'll use this kind of like a coordinate measuring machine, and I'll go around to the different holes and, record their coordinates. Then I will generate the G code, send it over to mock, and then I'll be able to do a hole layout. Like, so let's say I had a part that had 4 mounting holes. I would take 0, 0 off of the corner or off of one of the holes. I would get the coordinates. Then I would put a plate down, like the mounting plate, and I'll be able to lay the holes back out. And what I'll probably use is like a bushing, and I'll have different tools that can go in it, like either a transfer punch or like a stylus that'll help me zero right in on the part. All right, so right now we are, let's see, I'm going to line this up to 0, 0. So that is our 0, 0 point. I'm going to hit 0 back on our thing. So we're starting from scratch. All right, so I'm going to go to, this is my 1-inch mark. Now I'm going to go to my, whoops, forgot to record it. All right, so I'm at my 1-inch mark. I'm going to hit record, save point. Now I'm going to go up to my next one. I don't want to bore you guys with like a really long video, whatever. Save that one. Now I'm just going to hit some of my grid points just to get some motion into the table. And everything should be calibrated pretty good between the two. I actually use the rotary encoders to help me figure out how much of I marked a line on the pulley, and then I used the rotary encoder to go 1 full revolution to see how much the belt movement was for the pulley diameter, because my math calculations were coming up just a little bit off. All right, I'll make this my last. Well, I'll do one more after this. I'll go back home. All right, 5. So now I got, this will be my 6th point. Then I'm going right back to my home position. All right, hit record again. All right, so now what I'm going to do is I'm going to generate the G-code file. I'm going to transfer it over to my mock machine. Eventually, this will be all on the same machine, but for development, I'm just doing it separate right now. And we'll be back with a replay in a second. All right, so we've loaded up our G-code file in Mach 3. We are zeroed out. There's what our toolpath is going to look like. And I'll give you guys a front row seat for the replay. Everything's going to be in a rapid with a 1-second dwell between points. So here we go. All right, so we were able to successfully replay all the points very accurately. So first test is complete with points. Now what we're going to do is we're going to record a toolpath. Like we're just going to trace a weird part, and then we're going to replay that. So that way we don't have to like lay it out in a CAD program. We can literally just trace a part on the table and have it replay. All right, so now we have a complex path that we want to trace. I've added another button that is going to record every movement to a file. So I've zeroed it out. I'm going to start recording. I'll just do the upper body. This is a little bit jumpy, you can see. So the quality of the path might not be what I was hoping it would be. Very good for points. There's got to be a way to smooth this out. Maybe it's just skill. Maybe it's, I mean, with a plasma cutter, that's perfectly fine. And that's mostly what this is going to be for. So, all right, so we've traced out the upper body. I saved the points to a file. I'm going to transfer that, and then I'm going to replay it. We'll be back. Right, so we got mock loaded up again. We got the path. Now, the path actually has like 1,700 points on it because it was recording down to like the 1,000th of an inch. So even though it's going to be in rapid mode, it's going to go slow just because there's so many points for it to hit. So I have to implement some filtering, but I'm going to show it to you as it is. And then, I'll just do the rest of that later because that's not a big process. So what we're going to do is hit cycle start, and away she goes. You can see it's a little bit jumpy. So I'll have to figure out a way to smooth that out. But overall, the technique seems valid. Recording a path and then just being able to replay it without having to you can do all your stuff like right in the shop without really, having to sit down and spend a lot of time at a computer. And especially for recording the points, like for hole patterns and stuff like that, or just using it for offhand measurements of parts. I think that'll be quite handy. So I'll keep playing with it, but the concept is proven. So now it's just a matter of refining it a little bit more. All right. Thanks, guys. All right, I'm starting to lay out the frame of an XY machine here. I'm going to have steppers on it. I'll describe what I'm doing a little bit later, but right now I want to kind of go over some of my mock-up techniques. I spend a lot of time on the computer thinking things out, and when I'm in the projects mode, I don't want to do that. So I do things kind of a half-ass way, but they turn out pretty good. So like to start, I want to cross member. I need the hole spacing for, this. So in order to get, and again, we're kind of in mock-up mode. We're not doing final parts here, but it's like the first thing I might do is put a piece of paper over the holes and hold it down securely, and then push a pen through each of the holes to get the hole layout. So I don't have to measure anything there. And then in order to like set the spacing on those, so we can see that this gave me like that lined up perfectly for me on both sides. And then in order to set the width of the pieces, really I just kind of rough set how far this piece is going to be. And instead of trying to like screw these down ahead of time, what I'll do is I'll put the screws in and tighten it, and then I'll set the width based on the bar that I made. So that way the bar doesn't have to be at an absolute perfect width, and it makes the fabrication go an awful lot faster. And if all of this worked out in my mock-up, then I could just transfer these holes directly into the next piece or whatever. I've also left my base kind of big so that I can once I get all the pieces aligned and set in there, and I know I have enough room for my stepper, and I'm going to have an encoder over on the other side. Once I get the rough idea of what I'm going to do, it's much more organic to just let it grow than it is to try to pre-plan everything. All right, so we'll be back a little bit farther along. Another example of this type of technique is, I know those are 8mm rods, but all my drill bits are inch size. So in order to find the one that's like the closest fit to them, you can just use a set of calipers. You can adjust it until it's tight, lock it in place. You don't have to do any conversions or anything. and then just go across your drill bits and wait until you find the one where these just barely slip on, and you know that you have the right fit because you are physically transferring the fit across and seeing how they work relatively. I mean, you don't really care what the numbers are. Another example is for those cross pieces, I'm going to have some uprights. So just kind of laying it out by eye. I cut two pieces exactly the same. I just did a little bit of hot glue to dab them together. I usually use this trick when I'm doing steel, and I weld two pieces together. That way I can drill through both at the exact same time, and I know that all the pieces will be identical. And I just kind of line the bars up and set holes. So now when I drill these two are going to be identical because they're drilled at the exact same time and all the edges are aligned. Then we have our rods going through our essentially press fit holes. Again, we could test for the parallelism. We can see that that's tight, and again, without any measurements, that's tight. Now, because this distance has already been set and we have a hole pattern that we're going to have to align, we can't use the trick that we did last time of setting the bar spacing based on whatever the hole pattern worked out to be. So in a scenario like this, all you have to do is use a clear piece of plastic, just set that over, then by eye you can mark your center holes, and you can get the holes pretty tight. Like, you don't really have to drill them oversized. Of course you can drill them oversized if you run into problems, but these are just some of the kind of prototyping techniques that I like to use to move projects along pretty fast without having to be like super anal retentive about lining everything up and measuring everything, and using a mill with the dial cranks and stuff. And these techniques are really developed from, I made a Gingrey shaper when I was in my early 20s, and these are like kind of turn of the century machining techniques, basically. And one part on a machine isn't going to line up to the part on the other machine, but if you're just doing one, what do you care? And it's much quicker than doing everything all precision and laying everything out and having a plan. All right, so our next stage of progression, we got our spacing set. And actually, I set the spacing based on, I got the two idlers down here, and I set it so that the root of this would be just a little bit above the base of that. And then I took my calipers and I took that center distance, and I made it the center distance from there, did appropriate spacing. I'm still gonna, it's a little bit rough. I still got to put some like playing cards under there to do the final adjustment. I figured that'd give me the best alignment. So we got idlers on both sides. I put a spacer in there before I glued everything, so that way I'd be assured that it would be free running. And then I got the encoder on that side, and I'll show you what that's going to be used for in a little bit. And then these are, I haven't set those yet, but basically I'm going to be running right over the rod, and then to clamp the belt, you can see that those pulleys are toothed, so it's got a toothed belt that'll go in there. And then I'm going to use these as double duty, and these are going to be the clamps for the belt. So the two halves of the belt will meet here, and each side will be clamped. So basically one stepper motor, and I did that anyway just to prevent the racking, just in case I do like a PCB mill, something that might have a little bit more torque on it, especially if this was all the way over to the side. And I had to drill out that to 5mm and 6mm, so this side had to be adjusted just a little bit. But that is going to one drive mechanism for the Y, and that'll be good. And next I'll get everything clamped together, and then I'll be mounting the steppers here. So that'll be the next stage.